Yeah.
Okay. Working at Capital One for about 5 years now. Actually, next week it'll be 5 years. During that time, I worked on several different teams in several different areas. So my first team, I was actually on very back-end database team. We were on like Spark, Python, Java, basically just data movement. And then I moved on to my second team, which was a lot of different things as well, but mostly C#, Golang, Angular for front end, and that was like very full stack team, and then Postgres for back end, that one. And then my current team, we're more front end team, which is we're using Vue for the front end, and then Node for like middleware stuff. But yeah.
All right, awesome. So which principle of object-oriented programming most helps manage complexity of a software model, and why?
Principle. I can't really say like, I don't know if there's like a list of principles or something, but I guess just the concept that the concept of objects or entities
so
simplifies the relationship.
Not exactly a principle.
Yeah.
I think you're familiar with them. They're the usual buzzwords that you'd hear for OOP. I guess if you think aloud, what are some principles that might come to mind? You can list them out and I'll let you know if they're principles.
Yeah. So I guess the fact that it's the object model is not a principle, or
I guess I mean like they're one words, like one word terms.
I guess entity.
Not exactly. Any other thing comes to mind?
Oh, you know what's a good one is I think of like an interface. I forgot the term when it's like not being applied, but it's not polymorphism, but
yeah, that's one. That's an example for principle. Yeah, so you say polymorphism, and why?
Yeah, polymorphism is a good one. Or just because polymorphism specifically, I believe, is when you can have like one function that does multiple things and has multiple inputs based on what's actually required. And so you can have what really I want to say is I forgot the one where it was like an interface where it's like you have the main class, like subclassing, where you can actually take like a parent class.
I think you're referring to inheritance, but it's in a similar line as polymorphism. So thanks for that. So we can jump to the next one.
Yeah.
Choose the most appropriate data structure for each of the problem types below.
Okay. Or should I just say it out loud?
Whichever is easier for you.
Okay. So a hierarchical file system model. Data structure, anything with a hierarchy, I'd say would be like something nested, not a tree, but like a graph, I would say. Okay. In that case, I guess it would be a tree, just not a binary tree. Mm-hmm. Yeah, but a tree.
Okay.
An undo, redo history in an app. For both undoing and redoing, if assuming like standard functionality, I would say like a stack. So it's first in, first out. Orders to be processed in order sequentially would be a queue.
Okay.
And then Boolean option flags in a memory constrained device. I mean, that could be probably the best way to do it. Might actually be like, or like a slice, I should say, where it's like there's a kind of everything's in.
All right. So thanks for that. So now for the next one. Give an example of why one might occur in code.
Yep. So race condition is sort of like very hard to recreate, but where one thing can happen before another, like in the wrong order, just because usually it's because of like concurrency, some issue with like concurrency, multiple parallel lines of code running. Actually, I dealt with this personally where we were taking messages from like a messaging system, like I think it was Kafka.
Yeah.
And we were actually inputting that data into our database, but we were kind of receiving on multiple lines. And so if we weren't careful, those messages we were getting from Kafka could alter the same lines of the database code, so it could be wrong order.
How would you fix a race condition?
So in our situation, we started monitoring the date.
But I guess more in general.
But in general, you would use like mutex or something blocking to prevent something like that.
Sounds good. So thanks for that. Now we'll jump to the next one, Web API concepts. I'll give you the first question. What is the same origin policy with respect to browser-based JavaScript behavior?
That's like a security thing where basically you're not really. It's not. How should I say this? When you have something that's grabbing something from a different website, it'll sort of block that code from running or working at all, just to prevent any security issues, because you can have things that will go in and grab your cookies and like pull down passwords and stuff from your browser. And so that enforces that everything is actually coming from the same origin or the same domain for security reasons.
I have a follow-up question. How can it be overcome? For example, an API is hosted on a separate domain?
Usually you can actually set up like in your whatever development or whatever code you're using, you can set up like config files and say, okay, this one's allowed. That's how it goes on at least.
Is there any other way it could be overcome?
Not to my knowledge. Yeah.
Can you give it the next one? What is your preferred way of serving multiple versions of a REST API, and why?
Multiple versions of a REST API. So like if you have like one line with one API, you can say just like the version, that kind of thing, not necessarily.
Yep. So basically, how would you implement versioning?
Yeah, I've done this a few different ways. My least favorite is actually putting it in. I've seen it put it like in the JavaScript or like the content area, but like most code editors don't or languages don't like that. So I just say like a parameter. It's an easy way to just like add question mark equal version equals whatever.
And where would that parameter be?
In the query string.
Okay. And why is this your preferred way?
Basically, I feel like most editors are not editors. I should say linting.
Yeah.
So I've had trouble with putting it in headers before because the linter doesn't like it. So that way, since you don't have like your linter constantly going, no, we don't like having it in this area.
Okay.
But really, any header would work as long as it's linting.
Okay. So now for the next one, how does a browser get a cookie from a web server, and how does a web server get the cookie from the browser?
Does a browser get a cookie from the browser? Does a web server get a cookie from the browser? So the browser would get a cookie from the web server by just like standard networking calls, right? Like this.
Yeah. More specifically, how would you get the cookie?
Like an API, like a REST API or something.
Yep. And how would the web server get the cookie?
And then has the web server get the cookie from the browser. I mean, yeah, same way. Or yeah, I guess so, because just from the client into the browser, and from the browser into the client, or from the server into the client, there's client to server. So now you can pull it out of HTML, but.
Yep. So thanks for going through all those questions for me. So now we'll jump to the coding section. String has at most one matching word inside of it, and the letters of the word don't need to be scrambled. Don't need to be contiguous in a string. They can be scrambled up and appear anywhere. And if the string doesn't have any of the matching words inside of it, your function should return none or null, like you see on line 15 for the third test case. String 3 has none of the matching words, hence why the output shows none or null. Whereas for string 1 in line 9, that string has cat inside of it because it has a C, an A, and a T. So you can take some time and read through the problem some more. When you're ready, you can let me know what approach you want to use to solve the problem. I want to describe the approach, then you can get started coding.
Sounds good. There are a couple ways of doing this. How long can that, I guess, string be?
Within the bounds of an integer.
Okay. Okay. So I guess my first instinct is to take this string, convert it into like take a loop, just go through it and make it a map.
Okay.
And we're basically the key will be the letter, and the number is how many times it occurs, so we can keep track of the number of things.
Okay.
And then just go through each of the words and just say, okay, is there a C in here? And does the count match? And then adjust the count accordingly. And the first one's able to hit it, go through. And then and if it doesn't match whatever letter in that order, just go to the next one and then return nothing if none of them match.
Yep, that sounds like a good approach. So you can get started when you're ready.
Yep. Let's do, what do I want to call this? So check word. So this is then taking string. That would be. And then we want to output the words that's also a string. So I guess we can start with actually mapping out the scramble string. Scrambled now. So what we can do is we can go through each thing of the string. So we'll say for, oh, it's taking words. So it should be words, and that's so for letter and scrambled. We can create scrambled map, an empty dictionary. For each letter, you want to get, so that would be scrambled map. And then it'd be letter, we want to default it to 1, it's not in there. And then what we can do is we can say scrambled letter. Let's do 0, we can do that. So that should say, we're going to go through every letter in this scrambled thing. We're going to get the current letter, if it's not in there, we're going to default it to 0, and then we're just going to add 1. And that should, I think, do it. So it's actually, scrambled map. Just replace. What don't you like? Which one of these has doubles? Oh, string doubles. K or B. Oh, you know what I should do? I don't think it does anything different, but okay. String 4 has 3 B's, doesn't have 3 B's, yes. And then 1A, 1Y, it looks right.
Yep.
Okay, let's move on. Right, and then, so going through this, we've got a map. So now we want to go through each word and words and look through all of those for each letter in each word. So for word and words, for letter and word, don't necessarily like that's going to be n squared, but we'll optimize that later, potentially. So we'll say if, I want to check if that letter is in our map. So if, the letter in the scrambled map, if it is in the scrambled map, what we want to do is we want to decrease that value in the scrambled map. So scrambled map letter should be nice equals 1. It should be letter in scrambled map and scrambled map letter. The letter should also be greater than 0. So else, break, because that means that word's going to work. And we're going to do that for every word in words, go through that map. And then how we want to determine if the word was made. That's the question. Well, so we do that for word in words. You could just set a flag. There's definitely a better way to do that, but I'll just do that for match equals false. Actually, set match equals 0. We can also say match equals 1. So we're going to count, and then if we counted the number right, that would be it. Still kind of like a flag, but so I'd be matched. So if matched is equal to the length of the word, if the number of letters that were matched is equal to the length of the word, that means we match everything, which means we can actually return that word. Okay. And so it only has one at any given point.
At most one matching word, yeah.
The other thing we could do is check the index, but I'm going to test this one out first. Yeah. Just make sure my log goes down. And then if nothing, we return none.
Okay, so we're going to run all of them, so you can just copy and paste all 6 at once.
Oh, so just like...
Yeah, you can just copy and paste all 6 calls. Or you can just print result from each of them, if that's easier.
Let's do that.
Okay, so we have an issue with the last one, but everything else looks good.
Okay, so bread making, BIRD. What was your issue there? BIRD. It doesn't seem to be casing issue, although that's something I should have asked about. Should this be case sensitive or case insensitive?
We can say insensitive, or all the letters will be lowercase.
Okay. E, I, R, and D. So it's able to find all the letters. So what was happening here? You want to find. And actually, let's see this where you keep looking. Not gonna go through everyone. Okay. What? Okay, so like it. C, B, A, B, D. Because B was not. Oh, I see what happened here. The issue is this rail map is not getting reset. Okay. So what can we do? I think we might be able to copy. I'm going to do some documentation research. I don't have to keep copying it. Okay. It's dictionary.copy. Which is, unfortunately, will be more space, but let's figure out, make sure that's the actual error. Yep, that was good. That should work the others still. So at this point, I should really optimize this because I believe this is, I don't know how long the copy operation takes, but I'm sure it's not great. Okay, so this part I think is fairly sound.
Could you run it again so I can see the whole results?
Yeah.
Yep, that was good. So what's the time complexity solution? And if you look on line 36, you'll see where we define W and S.
Okay. So maximum length of each word or string. So this part is just S or X, because that should be linear, just going through each item. This one, so let's go down here. Because we're using a map, this should be constant. Because it can just say, okay, we can find it or we don't. So this would be O of 1, and then we go up. We're doing O of 1, an O of 1 operation for every letter in the word, which would be O of S. Should be comma. And then if we go up here, we're doing that O times S up to W, because we're doing that. We're going through each letter in each word W times, I guess, at maximum. That obviously cuts out early, but assuming worst case, it goes through every single letter and the last letter is the only one that's not there. Right? Yeah. Every letter, every word, SW. So the entire function would just be this one, SW, because this one wouldn't matter because it's substantially lower and it would kind of be negligible.
Yep, so W times S.
Yeah.
And space complexity?
Space complexity. So let's comment these out again. Although honestly, I think it's just the length of like 2 maps would be the space. And then yeah, so there's not like recursion or any heat being done. So yeah. The heat, or this would be O of S, or would be space complexity.
Okay, you said O of S.
Yep.
All right, so thanks for going through that. So this time you're going to be given a grid of individual letters and
Okay.
a word, and I want you to add a function that takes in the grid and the word as inputs, and I want you to return a list of coordinates for the letters of the word inside of the grid. We'll say the word can start anywhere in the grid, but consecutive letters can only appear immediately to the right or below the previous letter. I will say the word is guaranteed to be inside of the grid. If there are multiple matches for the word, you can return any one of the matches. So if you look on line 27, you'll see for the output for the first test case, given grid 1 and word 1 its inputs. So word 1 is defined on line 15 as catnip. So again, you can take some time and read through the problem some more. Then you can let me know your approach, and then you can get started coding.
So it's like 1 cat. Oh, cat. No. Okay, so it's almost like a word search, except it can be scrambled.
Yeah. Mm-hmm.
All right, okay. Location of the word and most coordinates. There are multiple matches. Return only. Gotcha. Should I comment out this one or just kind of leave it?
It's up to you.
Okay. I'm tempted to just start with like my easy option, which would be just basic greedy algorithm, go through everything, see if we can find it. There's probably a way to save time
But
doing some other things.
How exactly would you find the coordinates?
Like a nested for loop.
How would that work here?
Actually, yeah. How would that work? Well, yeah. So what we would do is we could, maybe that's not a for loop. We would want to find basically each time that we see the first letter. I guess recursion actually might be the best option here,
Mm-hmm.
to think of it.
How would that work?
Because what we would do is we would jump in, we would find the current, every time we see the current letter, we would want to find the next letter, which would be below or to the right. So it should check if below or to the right is 1, and if it's not 1, it would just jump back up and say, no, this one isn't 1. If it is there, it could go to the next one and say, okay, I'm to the right and down. Yeah. So just consistently checking if where the next letter is, and then once it hits the end of the word, we would say, okay, it's here, because it's ensured it will be there, right?
Yeah.
Yeah. It's ensured it will be there, so that will be like the return case, or what is it called? End case. I forgot what version words. But that would be the end case. It's like the word matches, and we would exit out if it doesn't match, and then that would hopefully return the first one it sees, because it would just return back up until it found it. There's probably some checking I need to do with what is actually returning, but I'd have to probably get my hands into the code before I could determine that.
Yep, well, your describe sounds good, so feel free to get started when you're ready.
So this would be, I'll call it word search. It's technically word search. And the inputs are given a grid and a word. So grid, not the word grid. Grid is a list of lists of it's a string or character. It doesn't matter. The chart. And then the word is going to be a string. And this is going to return a list of coordinates. So it's actually going to return like an array of tuples. Yeah. Would that be correct? Like an array of tuples and numbers?
Yep, that works. And you can use any data structure you like.
Okay. Okay. This will probably have a helper function at some point. So we have this grid. What we want to do is we want to, I guess, just find the first element. That would just be a loop. Yeah. Yeah, and this would be technically a double for loop, but it would basically be treating itself like just flattening this out, just sort of making sure we're going through each one. Boolean grid. For item in the row, actually. For each row on grid, for each item in the row, we want to basically check if it's the same as the first word. So we have this word. And actually, yeah, after we get past this first one, we don't have to touch this again. So we can just argue this word here.
Okay.
Might have to change that later. But I should also check, is there a chance that this is just going to be empty?
No, so we'll say it'll be empty.
Okay. Either the grid or the word. Word 0. So word 0 is equal to item, and we'll run our helper function and figure out what that is. Otherwise, we'll just do the next thing. That's what that would be. So we get the first letter. That would help us like initialize it. So let's do word search helper. So this one, we definitely still want the grid. We could actually probably concatenate the grid. That's too short. We still have this grid. We still need the word. We actually need remaining letters. I guess next letter. Because ideally we just get the next one. We just need to make sure we're keeping track of what the current word is. So we can check the next one, don't get rid of that. And then we probably some other things. All right, so we have this grid. We want to check if the right is the next or down. Sorry, I'm like it. Okay, so if remaining word if the remaining word is equal to 0, then down word do stuff. Otherwise, if you want to check remaining word 0. This we have to start thinking about what is this actually returning out. So if we returned out the current coordinate, then we could add it to like an ongoing list, and then if we returned like none if there was no coordinate. I guess just remove things like this. How would that work? Okay. So if we walk through and we said, okay, we found C, we found, I should just write the basic version of this first, really. So this is grid. So it has a current coordinate as well. So we have last coordinate there. So if grid last word 0, square 1, comma, and then right would be second line increases, and then row, and then down is down, right?
Mm-hmm.
Yep, and row would be the other one. And then we definitely have to consider what happens if that coordinate does not exist. But I should really check if this basic logic works first. So this would be if there's something to the right. If there's something to the right, what do we want to do? Well, I guess I could probably think of it like it's smaller. So let's say we're working with this one. A is itself. Watch, let's do a little bigger. Let's do like AB. Is it right if I use a notepad or should I be doing everything?
You can use a notepad.
Right. So we have AB. So we just need to find is the only string that's there. What we're going to do is we have this word search helper. It has A, it also has the coordinate 0, 0, passes through to it, and the remaining word right now is B. So what it's going to do is it's going to say, okay, remaining word, it's greater than, or it's not equal to 0, so we're going to continue on through this function because we have not found the full word yet. We're going to say, okay, if remaining word is in the next thing, next area, then we can return, or if the next letter is to the right, which it is in the example I have on here, then we're going to let them do now. So we have it, so we want to rerun the function definitely with the current last chord as the new one, the remaining word as the new one. We could have like, I guess, another list of the last coordinates, because then if we went down a different route, it wouldn't be continuously updated. So instead of that, let's do this. And then that's just actually the return of the function anyway, which is what we want. So that actually makes a lot of sense. Three chords. Okay. So, right, that's still return. This would actually return previous chords, so you've reached the end of the word. And then the last coordinate would just be, just for simplicity's sake, this is going to be if we pick it, the previous chord is going to be just actually the last element, which is -1. That should always have something in there because we're populating that here. This is actually going to call word search helper down here, which would be, when taking grid, it's going to take in the current chord is going to be basically have an array of certainly taking the index, which is, how do we do that? I think it's in memory, but I'm going to double check. And so this actually becomes I row, J, right, row. It actually has to have the index and not just going through each item. And that would be the tuple right here is IJ, and this is actually a list. So we initialize it with that item. So we also need to consider if the first letter was even correct. But we'll think about that in a moment. Or the next, actually. So we have last chord, previous chord, and if it's the right one, it's going to return word search word. That might not supposed to be returned. Grid. We don't want to append because that would just add it. So how do we? Oh, would add that to our current list. So your previous chords, chord and not chord, that was here. Previous chords, and then remaining word. We want to take off the first one, so just one out. That should subscript the array of the letters in the word, so it's only the last remaining letters. Should be the same thing. Problem is we actually want to return it. So if we return it, we can't go to the next one, which would be an issue. I guess we have to have something else that lets us know, okay, we actually made it to the end, and this isn't just a failure. My instinct is to make this other people have like a true or false.
Okay. Also, as a heads up, we have about 6 minutes to go.
Oh,
but you get credit for as much progress as you make if you don't finish.
Okay, thank you. So it's also questions and accent. Yeah, so go through that, we'll see that. We need to add another thing there. We'll do it later. Quick time, probably not. So we don't want to return for returns. That's basically cutting off that. So we want to say, I guess what happens, there should be another thing where we get to the end of the grid and it does something different. Okay. If we get to the end of the grid and there's nothing there. So let's have a fail case. I guess that one. Ooh, that would be bad issue. That's what I was doing there. So plus chord 1 plus 1. what would that be? You have a number of the row length, which is grid 0. Something like that. So that would be go to the row. That would be the column. So what do we want to do if this happens? If we return out, so what happens if we just return empty array? Let's stop that in its path. And so we could say, to be on here. So connected. So if otherwise we can get to it, we're going to return what we have so far. Logic starting to get weird, but I'm not sure if I'll So that would take care of that in case we actually have to get through each letter. There's no way this works for now, but I really just need to see an action just to figure out what's going on. So I'm going to run word search. Let's see if it works this one now. Okay. Invalid syntax with my typing assuming. Oh, I need. I was being silly. That's what that is. Oh, I was first.
All right, so we're about out of time now. But like I said, you get credit for the progress you made. So.